going? Any updates from folks?
At the start of the week, I tried to get some other loss functions working. Yeah, specifically like trying to get the dice loss function to work with the multi-channels. Obviously, like there's the problem of the argmax function not differentiating, and so I was trying to work around that. I sort of worked around it, but the results I got were never any better than I was getting with the standard loss functions. So I ended up giving up on that. Yeah.
So when you say not better, meaning were you able to like get back the same accuracy that you were getting, or was it worse?
It was similar. So
Okay.
maybe slightly worse, and like in the dice, it never matched the dice metric value I was getting. Yeah, like I wanted basically to have a loss function that was equivalent to the metric one I was getting, but I could never get the two to match up. So it was taking a long time, so I gave up on that, and yeah, I've reverted now just to playing about with my tiled images.
Okay. Could you post that function if you don't mind?
Well, sorry?
Could you post that function that you were using for the dice loss?
Yeah, sure. Yeah,
yeah.
I've got a couple, so I'll put both of them up or whatever.
Cool. Okay.
Maybe somebody else could figure out where I'm going wrong.
Yeah. On that note, I finally got dice loss working as well using another library, but even that library had to. There's a library called Cornea. I'll post the link, but which gives many of the loss functions. It apparently seems to be included when you download FastAI. I originally had thought I had to additionally install it, but for some reason you can access pretty much all the functions from FastAI itself. So I have some vague suspicion. This is FastAI version 1, number 2, but I still had to go in and modify. And interestingly, there are two ways, as Steve, you were pointing out last time, my code was wrong, and it didn't account for the multi-class situation, and this one does. But interestingly, they take a different approach of using a one hot on the target side, at least the code that Cornea has. But even that had problem because, as it turns out, the current target in our competition is, again, going back to the shape, it's B, the input shape, as Rikhil and I have discussed many times, is B, N's, and then HW, where B is the batch size, N is the number of classes, and then H and W are just the height and width of the image. Compared to traditionally PyTorch says for cross entropy and stuff, B star, and the star is just, all the other things. But so typically it would be B, then HW, but for our competition, it turns out it's B1HW. So that one sticking out, meaning B, the batch size, and then a single image with an H and a W. And what the the version of dice loss I used, I had to uses a one hot, making that B1HW into B5HW if there are 5 classes, for example, and then does the loss comparison.
Yeah, that's what I was doing. Yeah, I was expanding that up to get 5 on the target, and then multiplying that by the predicted.
Yes.
But the predicted, though, like it's coming in its probabilities, isn't it?
Right, because they don't have a softmax at the end. Because, like we were discussing last time,
yeah, last time,
cross entropy, that takes care of it.
Exactly. Yeah.
Right. So you get back logits from which are basically just probability values.
Yep.
But to your point, so I did get that working, and just ran it late last night. And just as you mentioned, interestingly, I get the same results you did, which is very close to what I got with the cross entropy, but my cross entropy numbers are 88, 89, and the dice loss based attempt gets stuck at about 85.6 or 86 rounded, whereas the cross entropy one is able to reach 88 point something. So it's close, but not quite what I get with just even the standard cross entropy. And and by the way, I posted last week, I don't know whether anybody had a chance to try it, the low-WAS softmax loss as well. I got that working with 3 different options. I think, forget the, one was a per image option, and the other one is whether to use all of the images in the batch or just all of the images in your data set, I believe, or just the images in the batch when you average, I think. Because there are some switches called all and present that you can toggle. And all 3 of the variants ended up giving me the same result of close but not exceeding, about in the same range, in fact, 85, 8.6 or 86 rounded, but still my first run with cross entropy is the best result I've gotten so far.
I didn't get to your function, but I tried training different low-WAS softmax that I found. And when I kind of started reading up, it kind of says use cross entropy and use low-WAS softmax as like a fine-tuning step. So they say first train with cross entropy, and then like towards the end use low-WAS loss. So from that, I understand that you don't want to like plainly train with your loss function being low-WAS. You want to change that towards the end. And as usual, there are like, even in the repo, whoever the author is for that, Max Berman or whoever that is, they send that there are so many hyperparameters with that. It varies with batch size, it varies with this, it varies with that. So yeah, I guess there's a lot of tweaking there.
Yeah.
And for some reason, I was getting much better answers with fit rather than fit one cycle. And yeah, but still both of them never came anywhere close for me, like to cross entropy versus it was like I think a good 5% off, and it took longer to train.
Yeah, you're right. I also observed that it took longer to train, not terribly, but definitely each epoch was about, well, I guess significantly longer, I should say, because it was like 21 minutes. I was doing it on Kaggle, and 21 versus 24 or something in that range. So minutes.
Okay. I was playing with purely Camvid just to see if everything runs.
Yeah.
I didn't even move to the semester one.
But the interesting thing what we read on the subject was, the scores with just cross entropy for me are about, I think, if the goal is to get to in the top 10%, I was still, I would say, probably about 3 or 4% away from the top, and about half that to get to the top 10%, if I'm not, about 3% on the private score, 2.7% to be exact, and then to get to the top 10% from where my score is, it's about 1.6%. But that 2.7 or 1.6 at least doesn't seem achievable with losses. I have one focal loss yet to try, because again, that has to be modified. Any focal loss implementation, I haven't gotten it to work with the multi-class situation yet. But that's the one final attempt before I move on to trying other things. One suggestion that I saw somewhere, which seems rectal, that you should be able to implement very easy because you still in a controlled small environment, is even in this instance, and maybe Steve, you can try it too, is I saw somewhere which said somebody got really good scores with equal number of all class, including obviously the node effect class, but equal number than the numbers that you just get by training with whatever you've got.
Right. Okay. Yeah. Okay. So that's what kind of brings me to what I was looking at, was passing in weights for cross entropy. So that is an explicit option which PyTorch supports, though FastAI, you don't see it in the shift tab, but then internally that also uses cross entropy, flat uses cross entropy. So you can pass in weights, which is the length of 5, because you have 5 different classes. I'm just finding a decent way to pass those weights in. I got it running, but I think my weights are not like reflecting how the classes are spread out. So yeah, that is something that, yeah, if someone wants to try, that's also possible.
How do you go about choosing the weights? Do you just sort of
I think it should just be
work
like
out what proportions of each defect is in the training set?
I would imagine that would be the case. It should be basically like total number of pixels with defect 1 divided by total number of pixels.
Yep.
Yeah, so something like that is what I would imagine should work. But yeah, that's what I'm kind of still reading up with that. So I'll let you know if I do find anything else.
Yeah, in fact, that aligns very well with what I saw somewhere, which said, so there are 5 classes, right? So use 20% of your samples for each, and then you get better results.
Right. Okay.
Do you know?
Which would say that when all the weights are equal, then you get better results.
Yes, or that. Yeah. Right.
Do you know if the person that was doing that, were they using the full images, or were they using the cut down tile images, or?
Good question. I don't recall whether he was using.
I would imagine it had to be tiles, right? Because otherwise,
as long as
non-segmented class would be, non-defected class would just be so much more.
Yeah, but that doesn't imply necessarily tile, right? Because you would just use the same number, as long as, and of course, you'll be bound by the lowest number, but.
Wait, when you talk equal number, you're talking of equal number of pixels in each class, right? Or are we talking about just?
I thought it was more like, each images of. I interpreted, and you bring up a good question, I have to go back and double check. I interpreted it to mean equal number of images with defects.
I see. So you're saying 10 images with defect 1, 10 with defect 2, 10 with defect 3, like that.
Yeah.
I see. Okay. Yeah, that might be good. Yeah, I'm not sure which one that is. Okay.
Because in this case, for example, or in general, you would have obviously the non-defect class will be dominant, right? Otherwise.
Right.
Yeah, so I know we were talking a couple of weeks ago about, could you get away without having any sort of negative examples in your training set if you were just to stick with the positive ones. I was looking back over, the guy that does all the tiling stuff, and he was actually talking about that, because he'd started off, all he was doing was taking the positive examples, and he was making his tiles, and then he was just keeping the tiles that had defects on them. And at the time, he says, like in the leaderboard scores, he was getting like sort of a 0.82 type of score. And then somebody suggested to him that he start putting in, the texture defects, the ones with the actual patterns on the steel. So he put them in, and he said he jumped up to about 0.87. But he said that then by putting in the negative examples, or he has like hard negative examples where he's trained the network on all his positive ones, and then he puts all the remainder of the tiles with supposedly no defects on them back through that, and works out which ones went wrong the most, and then from that he develops a list of the hard negative ones. And like with that, he said he got a few more sort of points. So he said he thought it was very important to have both positive and negative training examples in your set. So that's sort of what when I gave up on the loss functions, I decided to concentrate like on the tile thing. So I've gone back now, I've just been training with sort of 13 tiles per image, and like then upping it on the test set as well, because he does it just with single images when he's doing the iteration. So I've got like 13 images on that as well. But unfortunately, I just found out that the images that I was creating weren't quite right because of the fact, do you know, they've changed the data frame. So like originally when it had the image ID and the class ID, they've also changed it as well. It used to also have like an entry for every single image. So every single image in the submission file or whatever, or the masks file would have 4 entries per image, 1 for each of the defects. And they've actually changed it now. So as they've cut those out and they've only retained the ones that actually have defects. And it meant I'd taken the guy's like original code for slicing his images up and just used the new mask file with that, and it doesn't work right. You need to revert it back into the old format, because what I was getting was, I was like slicing mine into 13 images, 13 tiles per image, and basically it was just putting defect number 1 for every single one of them. So I thought like all my data was badly weighted. I thought I was going to have to like start doing this, but I just discovered today that actually it's because of a bug in the code really, and I needed to change things for the new format. So because of that, I've had to retrain everything. But yeah, certainly he says that you need to have the negative and the positive in there to get the better scores.
Mm.
Yeah, I think to your point, Steve, I did have to train with the negatives, and as you said, I don't know how much the whatever the patterns added, but I threw them in there as well because we had generated them. And I tried generating them. In fact, the problem you stumbled into was the first problem I encountered when I tried to do it. So I had to change the code to essentially make it make the input code the very first time when I reuse the code to slice it to use the new data format rather than the old one. So I had to go first update that before I change everything else. But yeah, to your point, it required, or at least the best code I've gotten is one that includes both the whatever the patterns he talks about as well as the negative examples.
Yeah, so at the minute he takes all of the pattern images, all of those texture images, and he slices them up into 6 tiles, and all of those go into what he classifies as his positive set. So they're always in, and then he takes 12,000 from his hard negative lists. Yeah, so but actually, like in the stuff where he's talking about it, he said that in retrospect he would have taken out the texture images and put them in the negative set. So
yeah.
that's
in fact, the interesting thing is he even, and I didn't dive into it, it's been a while, but that's one of my, I put aside the thing to dig into later, is he also prioritizes the negative examples by either probing the test set or somehow, I haven't gone and looked at it. He calls them hard negatives and he uses 12,000 negatives and he ranks them somehow.
Yeah, that's what I was like saying. Yeah, so he starts off and he trains the whole network just on his positive examples. And then he uses the negative examples as a test set and puts them all through inference. And finds which ones start showing defects when they're not meant to, and then he ranks them by the number of pixels they've shown as a defect, because obviously the more pixels they show of defects, the more wrong they are, because they're not meant to have any defects at all. And yeah, so like then he has a graph of the number of pixels for negative images, and then he takes the ones that have been the worst, and then he adds those into the main training set and then trains everything again. But
okay.
It obviously takes a long time, because you got to train the whole network first, all on the positive images, and then you got to do the inference, and then you got to get that set and then add them to the training set and train all again. So, and because my image slicing code was wrong, it's about 2 days worth of work. It's about 24 hours worth of training time there.
Yeah, Actually, the thing I did, and this is the one I was fighting with and I gave up, was, and I just started using his data, is this is the problem of, I have the code to generate that and I just wanted to save it. But that's where I ran into this huge problem of Kaggle not writing my output that I talked about a few weeks back of, I don't know whether it's the size, blah, 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 but it just didn't want to write the zip files and unzipping them. And so I finally just gave up and started using his hard negative images directly as input rather than generating my own.
Yeah, as I said last week, I've just moved everything over to Colab now, so I do everything on that. I don't use Kaggle apart from the submission.
Yeah, that's, I think, my laziness. I didn't do at the beginning. I should have done that.
But the results I'm getting are probably very similar to yours. I'm getting a sort of like 0.88 and a 0.89.
Yeah.
So I'd like to be able to break the 0.9 barrier or whatever.
Yeah. I'm about 1.6. If you get to 0.9, actually, I think the top 10% is 0.898 on a private score.
Right.
And I think the best I've gotten is 0.884. So it's about 1.6% away from the top 10%. And so I'm kind of now more in the hunt for, okay, what can get me up by that 1.5%, if you will.
How many epochs are you guys training for?
I'm just doing what the guy did. So you do four with a frozen network and then 15 unfrozen.
Okay.
Yeah, exactly that. And in fact, throughout all these different losses, I'm kind of sticking to it so I can do an apples to apples. And so far, as I said, LOAS with even the 3 options didn't give me that.
But I don't think that is a fair comparison because certain losses will just inherently take much more.
Yeah, no, right? You're right. It's not, but it's also like, there's another reason it's about 8 hours of
right. Okay.
training first. So I'm like, okay, 8 hours is good enough. And, at least I can run 3 different experiments if I'm still on Kaggle, unlike Steve. So I can run at least 3 a week. So, it's about 24 hours. And then the 4th one I tried once and it died. So I was like, okay. So with that, and to your point, the other suggestion that I saw somewhere and you brought it up to right now is combining losses, because the other thing that somebody said, well, you mentioned training most of it and then towards the end switching.
Right.
The other thing somebody else mentioned that I saw was not doing that, but using a base loss itself, which is a combination of
2 losses, right?
Cross entropy and something else. I forget what the something else was, but so your total loss at every step is the combination of cross entropy loss and another loss.
Mm-hmm.
And using that, and that's probably the last tweak besides focal loss that I want to try with losses. And then if none of that works, I'm just going to fall back on cross entropy and look for other ways to try and get the score to be better.
Cool. While you guys were reading about losses, did you come across this, or have you guys discussed micro losses, macro losses, and weighted in, like, for example, F1, these 3 options?
Good thing. Maybe we should discuss that. I don't know whether we discussed, but at least I poked into the micro F1 versus macro F1, which is same as micro dice versus macro dice, because in the context of the Human Protein Atlas, which was the last competition. But it would be worthwhile, I think, to maybe discuss that next week. And in fact, the other thing, as I mentioned, is while I got the lowest loss implementation to work, I think it would be interesting if people looked at the paper. At least I couldn't quite grasp the intuition of, okay, I mean, I can, say what the paper says, that it's more differentiable proxy, but what does that really mean, or why is LOAS any better or whatever? I mean, if anybody has any insights after going through the paper, I mean, I looked and I tried to read the, or I should say, I read the paper, but I didn't come away with any good intuitions. Like, for example, with say focal loss, that okay, it helps you not overweight the negative examples and thereby help you better differentiate what's in the foreground versus the background. I mean, so you at least, besides the math, you take away some intuitive understanding of when to use it versus not. In this case, it just seemed to be, well, it's mathematically more convenient, so that's when you should use it, but then it doesn't give any better results. So
I think there's a lot of hyperparameter tuning involved with that, because I've also been reading up on Kaggle where there are tons of people who have been complaining that it just doesn't give them better results, but then there are certain people who are saying it gives them better results. So I think it's one of those iffy ones. You need to nail your hyperparameters, right? And I think from my understanding with the implementation, I mean, my main takeaway was that this is a differentiable loss versus like something like IOU is not in this case. But yeah, like I also found it extremely hard to like something concrete.
Yeah, something to hang on to, or kind of develop some intuition of, oh, I want to use, and a general intuition takeaway could be that, okay, wherever you want to use dice and dice loss is somewhat of a struggle, but then, like Steve managed to code it. I found some other example to code it. And then I don't really get, okay, if you can code that, then, something mathematically better with LOAS, but okay, I mean, as long as you get one or the other to work, whoop-de-doo, right?
Right.
It's as you said the other week, I've always thought that like it's better if you can get like a loss that matches with the competition loss or whatever. So what you see is sort of what matches up with the public leaderboard score, but I haven't been able to get my dice loss to do that. But I don't think it's a problem with actually using the correct loss function. I think it's just to do with I haven't implemented it right.
You mean your dice loss implementation is?
Yeah, as I said, it doesn't seem to match with what the metric gives, and like the scores I ended up getting from it didn't match with the sort of the leaderboard scores. They were sort of different. So, but I think if I had a proper dice loss that did the multi-label or multi-channel, if it was working right, then perhaps you are better to train with what you're actually trying to achieve.
Yeah, the metric. But take a look. And by the way, I had a question on this. Is there a good way to post code, or should we just point to GitHub code or on Slack? I mean, because I think at least staring at what I post, it seems horrible. It's not formatted, blah, blah, blah. And
between those three codes, I think on Slack, that'll help too.
Sorry?
The 3 backticks, if you put that on Slack, that'll still format it.
Yeah, I thought.
I don't think you did the last one like that.
Okay, I'll try again.
That should just help formatting, but yeah, that's pretty much with that.
Okay, yeah, I'll try, because this dice loss, I struggled with it for a long time, and at least I'm reasonably confident that the shapes are all now matching up, and it is doing.
Yeah, I think your discussion about last time about the shapes not being an issue, I think it's because it was doing that flattening. So there you really don't care about that much about the shapes. It still works.
Yeah, except in the implementation method that this code I started with, it goes the other way than flattening, meaning it kind of makes the, as Steve was saying earlier.
Oh, you were one-hot encoding.
One-hot encoding the target, yeah.
Okay. Yeah, if you share both those pieces, yeah, I would like to try that out.
Yeah, I'll post that. I finally got dice working. I still have to struggle with focal, because that's the one that I also finally want to give it a shot and So the two experiments for me are focal and combination loss, and I have to still think about what I'll combine the cross entropy loss with.
Right. Okay.
And then I'll be done with losses, and might just fall back. And I think if anybody else can try the equal number of examples of 20% or whatever, and see whether that improves their score relatively, that would be interesting. Because I think, Stephen, correct me if I'm wrong, but well, I think I know for sure that because of the 12,000 negative examples and stuff, obviously there are not equivalent examples that are used in the way we go about training by using that guy's setup.
What was that? Sorry, the 12,000. Yeah, like
no, I was saying that I don't believe in the way we train that the numbers of examples for each class are the same.
No, they're not. No, they're definitely not. So yeah, I could look into that. Yeah, because like now my image slicing code's working properly, and I can see exactly what defects are on which tiles, so I can balance them easy now.
Yeah, that'd be a good experiment.
Multiple images with multiple defects, right?
There are a few like that. Yeah, they're not that many. Mostly it is one image would have one defect or something, but yeah, there's a few where I think the most I've seen is 3 separate defects on one image.
Thought I saw 1, 2, 3, 4 also.
Yeah, I had, in fact, I did this EDA very early on.
Right, I also had that. Let me see
the numbers, but I don't recall. But you may be right. But I think by and large, what Steve said is correct, which is there are a few, but the numbers are much smaller compared to the single defect classes.
Yeah, I think actually, as you say, like within the Kaggle notebooks from the competition, there are a couple of EDA ones or whatever, and they specifically look at that.
Yeah.
So yeah, I think there's only a few that have multiple. There's maybe quite a few that have 2 defects, but
yeah.
I think I've only found 2 images that have got more 3 defects. But because I'm breaking them into tiles anyway, then it's even less likely to have multiple defects on a single tile.
Yeah. Which would be interesting, to that point of, do you think that because of that, the model's ability to predict multiple defects is impacted, that actually the data had multiple defects, that it would somehow, if you tile, is that a potential risk, meaning that if in the original images you had lot or high number, I don't mean to suggest the current data does, but it's more a hypothetical question, that if you had multiple defects in the data set and you tiled, would you run the risk of your model not being able to predict multiple defects because it doesn't see as many multiple defects as the data set has?
Perhaps. I don't know. I don't know how you would test that.
And your final model that you're testing, you're tiling that too, right?
Yes, I'm tiling and then sticking the tiles back together. Yeah.
So I think if you're talking about the distribution of your final test set should be as similar as possible to your test set, I think you'd still be holding, if that is holding, yeah, even by tiling your inference at inference time, I guess you should be fine. But yeah, that's a good point. I don't know. So that's the issue with Camvid. Camvid is so well spread. I think there are so many of these classes, so it's hard to I'm trying to experiment for class imbalance and try to see how to improve, like if there's a particular loss, or like we were talking about micro and macro, like is there a better way to kind of force it to concentrate on the lower number of classes, that distribution. But yeah, I've not found a good way yet to test that out.
Yeah, I think, the only so far, and we worked, or at least spent quite a bit of time discussing this in just the previous competition, which was just classification, but it was still heavily skewed, the Human Protein Atlas thing. And I think by and large, and people were trying to get smooth working and stuff. I didn't see any successful attempt at implementing that. I think another person, I think by name Akash or something, he had joined the Kaggle group for that competition, and he tried, but he also gave up. I don't think there's any implementation of Smooth that's successful. But what I believe Steve got working, and I had some success with taking the code from Steve, was just duplicating classes.
Right.
That's right. Yeah.
Yep. Right.
Yeah, I remember that now. Yeah, like that's all they did. And yeah, like that's what I was thinking of doing here, because yeah, obviously it's easy if I've got like multiple tiles from each thing, I can just sort of put in the tiles twice or whatever.
Right.
Yeah.
Yeah. So that's what I don't know if that's what my idea right now, what I've fallen back to is actually counting number of defected pixels. And I'm trying to balance that out rather than balancing the classes like in terms of images with that. So you can have two images with the same defect, but one has like 100 pixels, which is defected, and the other one has 10.
Yep.
So if I'm trying to balance it out, I would replicate 10 times the one with the 10 pixels and then use just one from the other class because that has 100 pixels. That's what I'm trying to push towards and use that. But it's pretty hard to count that out.
Yeah, also this leads into what you were saying, and maybe, I'll see whether I can look into that and maybe talk to it 5-10 minutes at the beginning of next discussion or at the end of this micro macro, because
right.
That would.
Yeah, I have a couple of great articles that I found which really explain it well. I'll share it and then. Yeah.
Oh, okay. So if you already looked at it, maybe you can share.
Yeah, sure. You can kind of look through that. Give me 1 second.
Because that would be, and the other thing I was looking at, and we touched on it, I think, in one of the prior conversations, Steve had mentioned it or brought it up. In this case, and I saw the guy whose kernel we're reusing mention it too. In this case, in this particular competition, isn't it the case that you penalize more severely if your model predicts a false positive? Therefore, it is better to not predict a false positive.
Yeah, that's right. Yeah. So it's because of like the way they've got their dice score. So if you have a defect, if you predict a defect with 1 pixel and there's no defect there, then you get a really low dice score. Whereas if you were just to predict that blank, you would get a dice score of 1 for that particular defect. And like obviously they then take the average of the dice score for each defect. So yeah, there is that. That's why the guy when he does his thing, he trains them and he records like a threshold.
Right.
Then he goes through each layer and for each defect removes any defects if the number of pixels is less than the threshold he's calculated. So yeah, he prefers to have like sort of blank defects rather than sort of have a few defects, even though the defects may be right.
Yeah, that's what I was getting to. So if that's what I saw as well. And then in fact, when he predicts for the entire image, right, which is 256 by 1600 or whatever, he has to increase that threshold because it's obviously a much larger image than a 256 by 256 image.
Yep.
Right. And so where I was headed with this was, under that kind of a condition, Raquel, would your method still work, or I haven't thought through where, or do you know what I'm asking? Meaning, is your approach to making 10 pixel defect and 100 pixel defect and equating or trying to make the using 100 pixel defect versus 110 pixel defect, or 100 versus 1010, I forget whatever the thing
Right.
is to get. Will that have any impact, indirect impact on, or am I relating things which aren't related?
I think that is a good point. The reason, to give some background as to why I am keen on that is I'm trying to detect for work skin, sclera, iris, eyebrows, hair, background, blemishes, beard, and mustache. My model is doing pretty decent for the heavily weighted classes, but for it's not able to identify like eyebrows and like beard and mustache and all, just gets into like, because of texture, goes into hair. So either I need to find a loss function which weighs those the losses heavier on that, or there is somehow I need to like artificially create more data. So this was just something that I was trying to think of, another way of sort of a data augmentation, I guess. So that was the reason, and I haven't succeeded yet. So that was something why I was trying there and thought it probably is applicable here too. So I haven't fully experimented to get results. And then like again, if it works, I don't even know if I'll be able to give a like good explanation as to why it's working or why it's not working.
Yeah, but I think that's the thing about
right.
ML and especially deep learning is you do it. I mean, batch norm, for example, for years the explanation offered was just plain incorrect, but
it works. Yeah,
it works.
Right.
So,
yeah.
In your imbalanced data sets, I saw this one idea. I don't know if how easy.
You're very quiet, Mehul.
Oh, sorry. Can you hear me now?
Yeah.
Yep.
Sorry. Yeah, I didn't sleep too well, so I was just listening to you. For your imbalanced data set, one idea I saw is you would calculate the probabilities of each class in your training set, and how do you, and then use those as weights?
So that's what, so the weighted cross entropy, right, where you would pass that in, right?
I see. Okay.
Yeah, that also exactly, like again, counting those number of pixels was kind of tricky, so I haven't reached that. I mean, I came across that just day before yesterday.
Okay.
So yeah, that's something I will try, and I'll let you know how that goes. It's so much more easier for classification.
Yeah.
That's why I think we bumped into this in the last competition, and then the most practical thing that Steve demonstrated was just duplicate it.
That's samples, right? Yeah.
Right, and then that did result in improvement of score.
Right. Yeah, exactly. I don't know if the last time I pointed out, like FastAI2 has this weighted data loader, which does the same thing. You don't have to like explicitly increase your data.
Right.
You just tell it what weight to sample it with.
Yeah.
And that does the exact same thing. And yeah, I also got improved results on that for, I forgot which competition, but yeah.
Good. So I think the thing I would propose, given where we're at, is a few experiments, but also if people have ideas beyond the losses of what to try to get the score higher, this would be a good time to spend a couple of weeks maybe on things beyond losses.
I've heard about data augmentation. Someone on, I think this was another class of another segmentation, where they said the defaults from FastAI weren't that great and they had to switch some off. So I think experimenting with different data augmentation is going to be, again, like there is nothing concrete other than actually trying and seeing what would work and what would not work.
Again, in the notebooks I'm using, the guy specifically says that FastAI's augmentation has problems in that
Okay.
it's doing everything in memory, and supposedly like it causes like a CUDA out of memory error, and so he switches to using, I think they're PyTorch ones, but they're ones where they sort of get applied on disk and then it's not doing the whole batch in memory. So he's specifically not using the FastAI. I'm not sure is a FastAI version 1 problem, or is it solved in version 2? But yeah, so he is only using a couple of augmentations.
Cool. Okay.
I'm not sure. Do you know, like within the FastAI course, Jeremy's on about is it augmentation, where you take the two images and put them together and then
Cut, mix, and mix up.
Yeah, I've never tried using that. I was wondering, would there be any benefit in doing that, where you would take two images with two defects and stick them together and see how it gets on? But
yeah, I've never seen it used for something like segmentation. Classification is what I've seen. And again, the problem is it takes a lot more longer to train there inherently because you're making the data set much harder.
Yeah.
But yeah, for segmentation, how would you go about that? Not sure.
If you took two tiles that both had defects and you put them together, obviously you might have trouble if the defect areas overlap.
Yeah, right, exactly.
But yeah.
And then imagine you're combining something like with defect 1 and defect 4, and then you kind of do like 50% this, 50% that. I don't know if you'd end up with a different class altogether.
Yeah, I'm not sure.
Sure about that. Yeah, that reminds me. Like, has anyone tried label smoothing cross entropy?
Nope.
No. Okay.
Sorry, could you repeat that?
Label smoothing cross entropy.
Oh, no, I haven't. But that's the other side of mix-up, right? Meaning instead of data, you just mixing up the labels, correct? It's just the equivalent doing it on the labels instead. Right?
I don't. As far as I know, I don't think they're the same thing.
Yeah.
I mean, maybe at a very, very high level, yeah, like how you're distributing your probabilities for predicting which class it is, I guess you are kind of.
Yeah, I mean, maybe because if you recall, we went through the mix-up and label smoothing aspects of in, I think it was part 3, whatever, part 2, version 3 of the course or something, and I have to go, right? And so label smoothing just says that I'm not certain about the labels. Is that's
Yeah,
what I recall.
yeah. Because basically, when you have a softmax, you're going to get 100% prediction. Only basically, softmax is going to give you 1 only when you've put in infinity there, right? And that's never going to happen. Your weights have to be like super large. So that is one way of looking at it, where you're telling it, okay, don't give me with some certainty what your prediction class is and distribute the rest of it among the other classes.
Yeah, so it increases, if I recall, and based on what you just said, it increases, it reduces the certainty of the one class and increases the certainty on the other, or increases the distribution among them.
Right.
Yeah, those are things I just wanted to say if we're all about at the same level, barring a few experiments of trying a few more losses and trying this equalization or somehow trying to balance classes. And once those are done over the next week, then it will be interesting to see what else can be tried to get the scores to move up either at least to the top 10% or even higher, or as Steve was saying, get to 0.90. Because I think in that process is where we will learn the most going forward.
Yeah, I take it like at some point as well, the people who won this competition, like they all share their notebooks, don't they? So
yes. No, in fact, I already have bookmarked that, and if I think if everybody is okay, maybe now would be the time to go look at that, and I can create a table like I did for the last one, because I'm at the point where if I I already have the loss experiments running for the last one, and I just have to get the focal loss fixed. And if that's done, then yeah, let me take that action item and kind of create a table from those to say, here are the various things people have done, and maybe we can pick and choose and go after several.
Yeah. So I've got a couple of things left. As I say, I still need to I've just fixed problems and stuff, so I just need to put my latest attempt in and see how it does. And then, yeah, like I was going to try the balancing in the classes as you suggested. But yeah, once I've done that, that's probably sort of me at the end of the line for ideas or whatever. And so it would be worth maybe turning to look at the top kernels to see what they do.
Yeah. That's what I was thinking too, because last week I was beginning to bookmark some of that. There's, in fact, at the end of it, I can even post a link if people are interested. There's like a one summary link that Kaggle guys themselves posted of all the different learning and the good kernels and the top 10 kernels, not in order, but people who have posted what they've done or explained and stuff.
Yeah, that'll be totally worth looking at. Yeah.
Yeah. So I'll post a link to that, and then if possible, I'll create a table looking at those things of what specifically are new or different from what we have tried so far.
That'd be good. Yep.
For one idea for the image augmentation and the data augmentation. So sorry, I don't know if
You're very faint, Mehul.
okay, is it better?
Yes.
Oh, I need to move. Okay, I don't know what's going on. So there are three augmentation libraries other than FastAI. So the original one was just ImageAug, IMG, AUG, and then these some Kaggle grandmasters built Albumations. Right. So now I think Albumission at some point was included in PyTorch as an official.
Yeah, in fact, in FastAI 2, it's being swallowed up, I believe, Augmentation you're talking about, right?
Right, yeah.
Yeah, in FastAI 2, I think they've become native to FastAI, I think, and because I see in the in the library walkthroughs, you've seen him use that as part of the transform.
Okay. And then the last thing is, like even when we have all these libraries, it's kind of tricky, like what order of things to do, right? Like, so for example, do you rotate first and then do some, then maybe shear, or rotate and add some color, right? So one of the things I think we talked about it a little bit during when we did Protein Atlas. There's a library called Rand Augment. So basically, the idea is just have this random combinations of augmentations, and I didn't figure out. So you have a list of augmentations, like say stretch and rotate, blah blah. You have and there were two, and there is so you have n augmentations, and then each of them has some probability. And I just remember this because the person who came third in the Human Protein Atlas, they were the one, they used this Rand augmentation library, and it's the first time I saw it used in Kaggle.
Yeah, I think you had posted the link to it when we were discussing HPA, right?
HPA, yeah.
Yeah,
Maybe, I can go over. Now I'm curious about that paper. I can review that paper and like do a short presentation.
Okay, sounds good. Yeah, next week maybe we can touch on that and then discuss just a little. I think Rekil posted the link, and it'd be good to remind ourselves of what the micro versus macro differences and stuff.
Okay.
And during the week, I'll post the link right now, and then try to summarize what people have. What are the new things at least I find from that link, because there are like 15 or so different things in that summary link from Kaggle of what people have tried and what are some of the good posts or ideas.
Oh, one more thing actually that I think we should try at some point would be like increasing our batch sizes with like gradient accumulation and seeing how that affects or does not affect stuff.
Increasing the batch size?
Yep.
Yeah, I tried increasing my batch size from 16 to 32, and yeah, I just ran out of CUDA memory.
That's what, so I'm saying like with gradient accumulation, so we should be able to still increase it without having issues. You'd still effectively be doing 16 at each time, but it just accumulate for like 32 images instead of 16 images.
All right, sorry, I haven't tried that, or I don't know how to try that.
It's a callback in V2. I don't know about V1. I'm sure there must be some implementation. I'll see if I find something for V1 specifically.
Okay, cool.
I think it's just perfect. I mean, anything else anybody want to add?
Nope, just waiting for your 2 links and yeah, both your implementations, Steve. And yeah, Srinivas, both your links.
Yeah, we'll do.
Yep.
Yeah, we'll post and
here,
then should be an interesting one next week as we begin to kind of try to get beyond losses and see what else we could be doing.
Yeah.
Okay.